In this video, we're going to learn how to simplify trigonometric expressions using the Pythagorean identity. Now, here's a refresher on what the Pythagorean identity is. The Pythagorean identity is as follows. Sine squared theta plus cos squared theta is equal to 1. So why don't we go ahead and simplify the trigonometric expressions below using this Pythagorean identity. The first one here on the left, cos squared theta times sine squared theta plus cos theta to the fourth power. So one thing that immediately jumps out at us is we've got a cosine in both terms. Actually, we can pull out a cosine squared from both terms. So let's go ahead and do that. So pull out a cosine squared, get cosine squared of theta, and then times what? Well, times sine squared theta. That's our first term. And then plus what times cos squared theta makes cos to the fourth theta? Well, that's just, again, cos squared theta, because 2 plus 2 makes 4, exponent rules. And hey, look at that. We've got a sine squared theta plus cos squared theta. So all of this stuff right here, that can be simplified to just 1 using that Pythagorean identity. So really, we've got cos squared of theta, then times 1, which is just cos squared theta. Wow, much simpler. All of that up there is just equivalent to cos squared theta. Okay, let's jump to the next one here on the right. In the numerator, we've got sine the fourth of x, and then minus cos the fourth of x. And that's all divided by this denominator consisting of sine squared x minus cos squared x. When simplifying rational expressions, it's always a good idea to start by factoring, so why don't we go ahead and try to do that. First, looking at the numerator here. It looks like the numerator and the denominator are both differences of squares, so that should be relatively straightforward to factor. The numerator, let's go ahead and factor that first. So the numerator will become sine squared of x plus cos squared of x. That times the same thing but with a minus. Sine squared of x minus cos squared of x. And that'll give us our sine to the fourth minus cos to the fourth with middle terms canceling out. And we could factor the denominator, but one thing that jumps out at us is this factor right here in the numerator is exactly the denominator. So let's just keep the denominator as is. We'll just write sine squared of x minus cos squared of x. And then we can cancel this sine squared of x minus cos squared of x cancels with this factor here, sine squared of x minus cos squared of x. And we're left with just this factor, sine squared of x plus cos squared of x. And hey, that is just equal to 1 according to the Pythagorean identity. So there we go, 1. That is what this nasty expression simplifies to. Much more elegant than it appears. Alright, so now we've worked some problems using the Pythagorean identity, but let's not limit ourselves just to the Pythagorean identity as it's stated. We also have some equivalent forms that come from solving for the sine squared term or cosine squared term in the Pythagorean identity. So equivalent forms, if we solve for sine squared theta in the Pythagorean identity, we're just subtracting cos squared from both sides. So sine squared is equal to 1 minus cos squared. And we also have that cos squared of theta, subtracting sine squared from both sides, cos squared of theta is equal to 1 minus sine squared of theta. So now that we've gone through these equivalent forms, why don't we use them to simplify the trigonometric expressions below? Starting with this one on the left, the quantity 1 plus cosine squared minus sine squared. Alright, so first thing to do here is to expand out this 1 plus cosine squared. Let's do that. So we get 1 squared, which is just 1, and then plus 2 times 1 times cos theta, which is just 2 cos theta, and then plus cosine squared theta. And then we still have our minus sine squared theta. Okay, so at first glance, that might not look like it's gotten any simpler. but let's rearrange it so that a simplification pops out. Let's write 1 and then minus sine squared theta. Put that next to the 1. 1 minus sine squared theta. And then we'll write all our other terms, so plus 2 cos theta plus cos squared theta. And the reason for doing that is that this 1 minus sine squared theta, that's an equivalent form of the Pythagorean identity. 1 minus sine squared theta is just cos squared theta. So this is really just cos squared theta. And then we've got the rest of our terms, so plus 2 cos theta, and then plus another cos squared theta. So combining like terms here, we really have 2 cos theta plus another 2 cos squared theta. And we can factor out a 2 cos theta from both of those terms. It's times 1 to get the first term, and then times cos theta to get the second term, cos squared. So there we go. This is the simplified form of the initial trig expression. Okay, let's move on to the next one. The fraction cos x over the quantity 1 plus sine x, then that plus tan x. So how do we simplify this trig expression? Well, nothing really jumps out at us immediately, but maybe we can massage the expression a little bit so that a simplification pops up. In particular, I'm looking at this 1 plus sine x in the denominator here. That's slightly reminiscent of this 1 minus sine squared in the equivalent form for cos squared. So why don't we go ahead and try to get this expression 1 plus sine x to become 1 minus sine squared x. And hey, 1 minus sine squared is just a difference of squares, one of the factors, which is 1 plus sine. The other factor is 1 minus sine. So let's go ahead and multiply this fraction, cos x over 1 plus sine x. Let's multiply it by the other factor, 1 minus sine x over 1 minus sine x. So then we still got the plus tan x over on the side. Multiplying that through, on the top we just have cos x 1 minus sine x, and then on the bottom we've got our difference of squares, 1 minus sine squared x, then plus our tan x at the end. And hey, that 1 minus sine squared x, that's just equal to cos squared of x. So let's go ahead and write that down. We've got cos of x times 1 minus sine of x all over cos squared x, then plus tan x at the end. We can simplify this a bit, cancel out this cos x and reduce the power of cos squared by 1, so we just have cos of x in the denominator. And let's go ahead and expand out this fraction. So we'll have 1 over cos of x minus sine of x over cos of x. And sine of x over cos of x is just tan x. And then we've got our plus tan x at the end. We can cancel out this minus tan x with this plus tan x, and then we've just got 1 over cos x, which is equal to secant of x. So there we go. Nice and simple. So now we know how to simplify trig expressions using the Pythagorean identity and its equivalent forms. And in the future, we'll continue learning how to simplify trig expressions using other trig identities.